Hi everyone, this is Shannon Williams from Rancher, and thanks a lot for joining us for today's meetup. Today we're going to be talking about building a scalable CI deployment, and it should be a really good discussion. We're going to go through and talk about why people are using Docker in their DevOps processes. But then the real fun will be we're actually going to dive into how we do DevOps here at Rancher, how we use a really slick tool called Drone to do all of our builds in containers. We'll talk a little bit about testing, and then we're gonna actually meet the team behind Drone who's joining us for today's session. So it should be a really fun day, kind of a fun meetup, and hopefully very informative for everyone out there who's sort of thinking about how they want to do CI, CD in Docker. So as always, I have my co-founder and co-host here on our online meetups, Darren Shepard, with me. Darren, you want to say hi?
Hello. Hi.
For a change, Darren won't have to be doing almost all the demos, so we have other people presenting, but Darren's going to talk a little bit about some changes in Rancher. So a couple things we've added in the since the last meetup, as well as a cool new project that we're doing. So. For those of you who haven't been on one of our meetups before, one of our online meetups before, Darren and I are, tend to host these every month. We talk about sometimes topics in containers. Sometimes we try to show cool new things that we're working on here at Rancher, and hopefully, beginning with this meetup, we'll be having guests come and present cool tools that we think are really interesting and add value to people that are using containers. So. Yeah, really excited to have you here. You can see all of our details on the screen. If you want to get in touch with any of us at any time, Twitter is really great. You can also contact Darren on Freenode, or feel free to email us or anyone at Rancher. You can just send an email to info@rancher.com and it'll get sorted to the right person, or hit us on firstname@rancher.com. So Shannon at Rancher or Darren at Rancher. You can get a hold of us as well that way. Our other two presenters today are Bill Maxwell, who's the Director of DevOps here at Rancher. Bill, you want to say hi?
Hey, how's it going? Thanks for having me.
Bill's been with Rancher really since the very beginning. He's one of our first engineers and leads all of our operations stuff. He's going to be talking about our CI platform, so he's going to be doing a lot of the talking today and demonstrating the platform, going through how we built it. Bill lives out in Phoenix with Darren, so they've known each other for ages because they worked together at GoDaddy for a long time. So thanks, Bill, for kind of taking the lead on today's presentation and showing us a lot about what you've built. Our other speaker today is Brad Ridzeski, and Brad's the founder of Drone. So he is behind the cool tool we've been using. And Brad, do you want to just say hello?
Yeah, hey everyone. Thanks for having me, and looking forward to seeing how Rancher uses Drone and give you a sneak preview of what we have in store in the next release.
Awesome. Yeah, that's exactly right. Brad's gonna give us not just a slide, but he's also gonna give us actually show some demos of what's coming with Drone 0.4, the next big release of Drone. So as always, these things, I just like to put this out. If you've attended one of our meetups before, you should know all these things. If this is your first time, the big thing with this session is we really do try to run them more like a meetup than a webinar, and I think we're getting better and better at this all the time. But because this is a meetup and not a webinar, we really do encourage people to ask loads of questions. Kind of tell us if something's not clear. If you have any things that you'd like us to dive into, we're happy to demo on the fly. Show something that maybe wasn't clear, drill into something if we can. So there's a questions tab on the GoToWebinar console that you can use whenever you want to. Just call out a question, and between Darren and I, we're always trying to monitor that, get your questions inserted into the conversation and answered. If we don't quite answer your question, just keep sending follow-ups, and we'll try to get deeper into it. In addition to that, the idea between these things is to demo a lot. We really try to not just have slides. I think these things when they're just slides are a bit tough. Because of that, your patience is requested. These are all live demos with no canned things. So every once in a while, people's laptops crash, or we lose connectivity to a server somewhere. Something goes wrong. So bear with us. We're doing our best. Sometimes, if you've attended one of these before, you've seen things go wrong. Because of that, we also try to keep the slides to a minimum, or keep them moving quickly. Today we have a few more slides because we're going to kind of dive into some products and talk about things. But in general, the idea is state the problem, kind of dive into it, and then spend most of the time showing how to do things. So these are a little more technical meetups. I did want to add something that, as we start to expand these online meetups and invite people to maybe sort of start contributing proposals, we'd love to open it up to the audience. So if there's ideas that you have for things you'd like to see, for things you'd like to the demo, if you'd like to be a guest speaker, if you've got a cool tool or project that you think would be interesting, please email or text or tweet to Darren or I. We'll certainly get back to you and look for an opportunity to incorporate into one of these meetups. We have them every month or so, and they're a great chance to to sort of talk containers. And then, as always, we're trying to give stuff away. I apologize to anyone who I owe a shirt to. We ran out at DockerCon, and then it took forever to get new ones in. So I just got a huge batch of new shirts, and they're all going to be going out in the mail in the next week or so. So if I owe you a shirt, I have a nice long list of people that I need to send them to for their cool tweets and comments from the past. These will be going out soon. I apologize. And in terms of today's sort of giveaway on that topic, I thought we'd do something kind of fun. I know a lot of people that are attending these are already using Rancher and have Rancher set up, so I thought it'd be fun to basically open up for anybody who tweets a screenshot of their Rancher environment of any kind. Feel free to gray out any private details you don't want seen, and it can be small, big, or little. Tweet something out with a picture of what you're doing and hashtag it Rancher Meetup, and that's the prize this week. You will get a shirt if you do that. So you can also always follow us on at Rancher Labs and keep up with the latest of what we're doing. We always post all the meetups on there, so if you're not following us there, please do. The other thing is, if you're on Twitter today and you want to chat with other people who are attending this, we still haven't really figured out a good chat mechanism for these meetups. So use the hashtag Rancher Meetup, and you can talk with other people. Follow that hashtag. It's a good approach to just connecting to people that you want to talk with who may be attending as well. Give your opinions in an uncensored, unfiltered way. Okay, so today's agenda. Getting right to it. We're going to have a really quick discussion about something new that we just blogged about this week. And it's called Libcompose. It's a project we worked really closely with Docker on. Darren's going to talk a little bit about that. Then we're diving into the core content. Why is Docker becoming so popular? I'll talk a little bit about what we're hearing from a lot of users that are using Rancher for these type of DevOps processes, big and large. Then Bill's going to talk about how we run our CI process here at Rancher and demo his implementation of Drone, Docker, and Rancher. Then we're going to turn it over to Bill to go through the latest and greatest on drones, so you can learn a little bit about this project. Feel free to fire questions in, and we'll pepper Brad with all of the latest, all of your questions and requests for features and things like that if you're a drone user out there. And then in the end, we'll sort of wrap up. There's a bunch of other things that we'll chat about, rolling upgrades, some big changes to load balancing. So a bunch of things that we've added to Rancher since 0.30 or so. If you're interested, stick around. We can go through that. If there's time, Darren will demo a few of these new things. So we can, if you've got Rancher questions and you want to get into detail on anything that has to do with Rancher, that's sort of off topic from the CI stuff, feel free to leave that to the end. Okay, so first things first, Darren, do you mind maybe kind of hitting this? Just tell us a little bit about this Libcompose project that Docker just announced, and that I know you worked really closely on over the last couple months.
Yeah, you can hear me fine, right?
Yep, you're coming through loud and clear.
Okay, great. Yeah, so I wanted to talk about a little bit about Libcompose, just kind of basically what exactly this project is, why we're involved in this, why we kind of helped build this, and then a little bit of history of where this came from. And so basically what Libcompose is a pure Go implementation of Docker Compose. From a technical perspective, if anyone's dug into Docker Compose, you'll see it's written in Python. And so what Libcompose is, it's written in Go, but it's also done in a library format. And this is really important because, one, there's just a very practical need that seems to have come up recently as people are wanting to integrate Docker more into their products and tools and things like that. They would really like to be able to programmatically interact with Docker Compose from their application. And so basically the first major reason why we needed this was we just needed a library that had Docker Compose functionality, not just the CLI. But even bigger than that, like this is one of the reasons why we're involved in this is if you look at Docker, you have the Docker CLI, so you can launch a container. But if we're talking about microservices, you really care about the relationship between these things. Your application is multiple containers, and this is growing to there's more things that Docker will start managing. Volumes, networking, and service discovery are all things closely in the pipeline, and so we really view Compose as a really important tool because it describes your entire application. And so by building this Libcompose project, we've really focused on pluggability and extensibility such that we can continue to enhance the Docker Compose, the format and the implementation. And eventually the goal of Libcompose is that, as we continue to build this and we get, kind of one-to-one feature parity with what Docker Compose already has today, that eventually it will become like the new Docker Compose. And so we really encourage people to try it out. It actually does, it's fairly complete right now, but there's definitely bugs. We just launched this. But we really want people to try it out. So what we've done is it's not just a library, there's actually a CLI version of it too that looks and behaves just like the Docker Compose CLI, but it's called Libcompose CLI. So just a little bit of a history of where this came from. This really came from Rancher OS, which is it started with Rancher OS, and then we continued to build kind of use Compose more and more in Rancher. But when we built Rancher OS, once we got kind of the basic thing of like let's get Docker running at PID 1, we had to tackle the problem of like how do we actually describe what are the containers that are running in the system, and then if people want to be able to add more containers to add more services to the operating system, how do we describe that? And the very obvious choice was, well, let's use a Docker Compose syntax and the behavior of it and everything. But we ran into initially just a technical limitation in that Docker Compose was written in Python, and all of Rancher OS is in Go. So we kind of embarked down this path of like, well, let's just create a simple implementation of Docker Compose. And at that time, we didn't really have like grand plans for this or anything, but we were just, it started off as a small amount of code. But as Rancher OS has matured, we've added more and more to it. Now, if you've used Rancher, not Rancher OS, but Rancher, our the management and orchestration product, we have a tool called Rancher Compose. And the idea with Rancher Compose was that we really wanted to stay as close as possible to Docker Compose. But there was a couple things we needed to tweak here and there. And so when we set out and we started building Rancher Compose, it was just kind of obvious of, well, let's just use the code that we already developed in Rancher OS. So we were able to share that code between those two projects. Now, so we had built up this code base, and at DockerCon, this last DockerCon, this just kind of came up in passing as we were talking to some of the core Docker developers that, we had kind of accidentally re-implemented Docker Compose in Go, and it was fairly complete implementation. And to our surprise, there was actually a huge amount of interest in this because there's various projects people are doing, and they see a use case of, hey, here I could actually, use this library and integrate it into my application. So based on that, after DockerCon, we decided to kick off this project, and so we've been working on it kind of behind the scenes, refactoring, getting everything ready, and we just finally launched it this last week. And so, it's out there. There's an official Docker project, so you can find it on the Docker's GitHub repo, so docker/libcompose. And we really, really encourage people to try it out. It's the fun thing about a project, like this, it's very early, so it's great to get involved and contribute. There's a lot of low-hanging fruit of fixing bugs and things like that, and so we really encourage people to check it out. So, Shannon, I'll pass it back to you.
Awesome. Thank you. And just there was a couple questions that came in during your session while you were talking there, Darren. One was, can you explain the difference of how Rancher itself is different from, there's kind of two high-level Rancher questions, I would say. One is, can you explain the difference between how Rancher itself is different from just Compose? And then another was, what's the difference between Rancher OS and Rancher, these are tools. So
Sure.
I can probably talk a little bit about that in my slides as well. So maybe the second one I'll deal with, how are Rancher OS and Rancher different. I can talk about those a little bit. But maybe you can talk a little bit about, you might need to answer it at least at some level before we go forward.
Yeah, and so the idea, so how is Rancher Compose different from Docker Compose? And so we very much wanted to stick to the behavior of Docker Compose. Like if we could have just used it right out of the box, we would have loved that. So there's two main things that are different. Is one, the default behavior for Compose doesn't lend itself very well for production deployments because it's a little too easy to accidentally delete things or stop things. So one of the things you'll see that's different in Rancher Compose is that we're very explicit about options that might be stopping or deleting things. The second, and this was the kind of the bigger, more important reason why we headed down this path, was that we needed a little bit more extensibility because, as I was saying before, like right now Docker Compose just manages containers, but we see it as this way of managing other things too. You just have all these various resources that you want and the relationships between them. And so the very obvious thing that we wanted to manage was our load balancer. And we have a huge amount of functionality that's in our load balancer, and we needed some way to kind of get that in there. But our load balancer is not just a straight launch container. It's actually fully distributed load balancer, and it's kind of more complicated than that. And so what we wanted to be able to do was when you launch containers, those are just basically containers or services. But then for the part of the Compose file that's a load balancer, we really needed to go to the Rancher API and interact with the Rancher server to launch up to launch the load balancer. And so we ended up, we ended up needing to kind of create a more pluggable framework so that we could do things that are a little bit outside of the current scope of Docker. And this is one of the first things that we'll be trying to accomplish in Libcompose is how do we make it a little more pluggable such that people can manage other resources that might be important to the deployment of their application.
Awesome. Very, very helpful. Okay, and let's get moving then. We'll come back to talk a little bit more about this stuff if there's any more questions on this when we get to the next session, or the session at the end of this, where we'll talk a little about some of the latest on Rancher. But that's great. I really want to though jump now into talking a little bit more about DevOps, because that's really the focus of today's meetup, is to talk about how people are using Docker as they start to change the way they do DevOps. And what Rancher, for those of you who aren't really familiar with Rancher, we're a software company. We're about 25 people. We build two products. One called Rancher, which is a software platform for building like a private container service for your teams or your organization. And we build Rancher OS, which is a micro Linux OS that runs just Docker. You can get a lot of information on those on our website if you want to just go to rancher.com. But we work with lots of teams, especially on both these projects, but especially on Rancher, who are really DevOps teams, and they're really looking at how to build improve their DevOps processes using containers. And there's a lot of advantages. I mean, for those of you who aren't already using Docker, who are just getting started, I mean, they really, impact every portion of the DevOps lifecycle, from getting new developers going quickly by having existing environments Dockerized or ready to deploy as a Compose template locally on development machines, to doing kind of probably the best build you've ever done with like consistent environments that are created on containers, so using containers for builds, we'll talk a lot about today, to building out test environments that are identical to what's in production, to kind of upgrading processes much more frequently. I think if you're at CI and you're trying to get to CI/CD, Docker is definitely of a lot of value, and you'll see a lot of improvements in terms of that. And it really comes down to that fifth point, that in the end, as you start to deploy containers into production, the benefits of immutable environments that are just consistent throughout the pipeline makes it just so much easier to do upgrades and to bring in new code releases and to be confident that the code's going to all work well together because the testing was better. You really do see the entire lifecycle impact of something like containers. And from our perspective, it feels like I hope everyone can hear me okay. It feels like the big impact is that with all of this, the hardest part is sort of figuring out how to get started. Teams have lots of tools. They're implementing. They have many different ways to actually do DevOps, many different languages, and then on top of that, there are if you've been using Docker for any time, you'll see that there are lots of different Docker tools out there and approaches that are sort of coming around from different frameworks like Kubernetes and Docker Swarm and Mesos to a lot of different cool new build tools and other things. So anyways, as you're thinking about how to get started with all of this, we're going to try and sort of cover mostly today just use cases. What are the actual use cases that people are doing and putting all this together with. But from our experience, a lot of the conversations we're having with users, it really is this idea of a container service that tends to simplify understanding this problem and becoming if you haven't heard of a container service, container service really is I think the term was really popularized initially by Amazon when they announced their ECS platform, which is their EC2 container service. And the idea was a central service that where users could deploy environments and connect resources to them and then deploy containers in some kind of a managed or orchestrated fashion. And Google has theirs called the Container Engine, and most of these are kind of the initial implementations of this concept have generally been by cloud providers in the sense of on my cloud, here's a service that you can use. But in a lot of ways, when we talk to users that are using Rancher, this is how they kind of see Rancher as this open source tool for building a container service that is independent of clouds and runs on anything, any system that they may have. And so if you drill into that a little deeper, what that means is that that a system like a private container service, it generally gets consumed by DevOps teams. And as a team comes on, this service obviously has to connect to the user directory to say who's authorized and what teams they're part of. But effectively, what they're doing is they're deploying environments. And environments are basically pools of resources that can be shared with teams to then connect to their registries and deploy containers, deploy clusters of containers, deploy complex applications and compose environments, and effectively share all of that with other people in your organization. And the idea is to be able to do this not just once and not just on one kind of resource, but many times with different types of resources and even different frameworks. Today most people use Rancher to do this, use Docker Compose, but we've had lots of people start asking us to support Kubernetes as a framework type that you could deploy. And so we've started working with the teams around Kubernetes to make that possible. But the idea is a central service that really simplifies the container orchestration and management and provides a plug-in point for DevOps pipelines, as well as these moves into production, all of the ops tools you want to use to manage monitoring and logs and things like that. So the idea then is that within any
one of these processes, you really plug them into your services. So a good example is the build process, where a user starts a build, and there's typically, each team will have build environments similar to what we're going to talk about today and show. And as these build environments are set up, they're basically given resources connected to something like Jenkins. So Jenkins will typically deploy these slaves that are going to do builds. But then, as a user uploads their code along with sort of build instructions and a Docker file for their actual build container, you start to do the builds not in generic build environments, but actually for each release, users will push their own build files, Docker files for building, and build their code in kind of a very clean environment. And that clean environment means you have a lot less worry about some dependency that might be left there from something else or something in the past. Everything is being done independently, and the same for when you run your packaging or run your unit testing. Everything is done in sort of isolated containers that are deployed on this sort of build environment. And the build environment itself, is well connected into things like Jenkins, and because it's all exposed through sort of standard Docker CLI commands or consistent normal Docker API calls, you're able to just spin these things up very quickly and see them as they change. And it could be Jenkins. Obviously, we're going to talk today about how you use drone to do this, but the output of all of this typically in these type of systems is either artifacts going into a traditional artifact, an RPM, or if you're starting to use Docker for production or testing, actually pushing Docker images out to a registry. And this type of system can be auto-scaling and can effectively scale as demand increases. So as you're accelerating your DevOps team or you're expanding your development organization, and you want to be able to run builds consistent all the time. I mean, what we tend to find on our teams is that as we get near a release or a deadline or something's coming up, the velocity of these builds tends to accelerate dramatically. So having cloud resources that we can pull in and rapidly expand the size of a build environment is really compelling, and we'll talk a little bit about that later today with Bill. But if you are using things like Docker for testing and for your images, so that the output of this build process is a Docker container, very often the next step is then taking and deploying test environments. And again, this will typically be a fully different environment within your container service. So you'll have an environment for potentially for each test that's dynamically created, gets created by maybe the build system itself. Whenever a new test script and a new compose file for the test environment is created, users will upload those things, and the build being finished or the compose script being completed will trigger Jenkins to go and deploy this or Rancher to go and deploy this actual compose environment. So as Jenkins says, hey, there's something else to be done, or Drone says, go change this, we take that feedback and then go and implement the test environment based on a compose script. It's usually different than production in some way. It may be, there's a different image that's being built, or it may be using a different database that's a test database, or it could be, that you want to test it at a specific scale, so maybe kind of a smoke test that you're deploying out there. So you'll have different types of build environments, sometimes many different compose templates for a build, for a new build of something that you want to test through. And often there's a test container that gets spun up to actually deploy these tests, and it sits on the same network. It can talk to these systems. It can run more complex test scenarios against it. So I think over and over again, what we hear from users is, as they incorporate, a lot of times they start by incorporating Docker and containers into their build process, and very quickly, they're looking at how to do this with how to push this into testing, how to automate test deployments. So Bill will talk a little bit about this as well today. And the final step, for most people then is pushing containers out into production, and looking at how within a production environment they can maintain and manage an environment using containers, using Compose. So again, the definition of the environment becomes critical. When you're bringing it up for the first time or when you're doing an upgrade, you're really moving between states. And so, the initial state can be defined in Compose, and it's usually a lot longer than this, but conceptually it defines the different tiers of an application. And then, systems like Rancher or Amazon's computing service will take these things and deploy them with, implementing a network between the containers, providing IP addresses, defining things like scale so that you can, scale the environment to whatever level you want it at now, or scale it further when you need more resources. Typically tools like Rancher will allow you to do HA and health checks to say, is this service viable? Is it well, actually, the way this type of stuff happens is a lot of times you're creating sensors in the network that are actually calling out to these different services. Service discovery is what's allowing these to scale and to detect each other, and then health checks allow those services to be monitored, and when something fails and a service is degraded, the system can detect that, can launch a new node, can auto-heal a service and reach back to sort of the target scale that it's supposed to be at. And so you're always, as a platform, you're always detecting and understanding where failures are happening and deploying further. And a lot of this is, kind of incorporates scheduling and service discovery so that you can, effectively define things like what are the relationships you should have between these different types of nodes. I mean, if I have a fixed set of resources in my environment and I define that, I want 10 Tomcat nodes, do I want those ever to be on the same host? Does it ever make sense to have 2 Tomcat nodes on the same host? Or do I ever want my MySQL and MySQL backup to be on the same host? So a lot of scheduling, a lot of affinity policies, things like that go into production environments that you may not consume in testing. All the way through to dealing with upgrades, and as you're rolling out new builds, new versions of your Compose template, being able to bring those up, test them, validate that they're actually working before then switching over traffic. And so a lot of cool stuff that users are doing with Rancher is really this. It's automating new builds, bringing them up much more frequently than maybe they did in the past, pushing out changes, doing rolling upgrades, which Darren will talk a little bit about later. It's a cool new feature that we just put in, and dealing with sort of the impact of those things, all the way through to a lot of the features that one of the big features that we're working on right now is how to then back up and do recovery of the volumes associated with these as more persistent data like SQL servers go into containers. We have to address persistent storage and backups and snapshots and recovery, and that ends up having a lot of impact. It looks like it's certainly going to have a lot of impact on DevOps, because not only can we start to think about using maybe some more persistent capability or persistent data in containers, but once we can snapshot environments or snapshot volumes, we can actually do a lot better testing as well, because we can snapshot an instantiation of a database that's running in production and pull that or some subset of that into our test environments and test against much more current and accurate data schema or database schemas and data sets for our application. So these are the kind of things that containers are enabling, and this whole process is driving, for a lot of organizations, big improvements in the way they think about their DevOps process. So for those of you kind of maybe are newer to Docker, why are people so excited about Docker, especially in DevOps teams? Hopefully this gives you a little bit of context for that. I want to turn it over now to Bill and let Bill walk you through a little bit about about the work he's done building out our environment. So let me switch over to Bill. Bill, can you should receive the little ball now and should be able to present your screen.
Okay. Showing.
All right. I see you.
You see me. Okay. Does the GoToWebinar thing show up, or can you just see the slides?
Yeah, you look good.
Okay.
No, I can see the slides, so you're good to go.
All right. So a little bit about the team at Rancher Labs. We're primarily a development organization. I think almost 80–90% of us are writing code and working on the product. We're QA in there, and they're writing validation tests and everything. We're distributed between Cupertino and our Tempe office, and we've actually got people, I think, in Russia and a couple other places around the world. And so, we've really focused a lot of our processes early on around using GitHub and the tools around that. So when we were looking kind of at our solution space, kind of getting early on, we wanted to focus primarily on writing code and not running systems at the time because we needed to move fast. So we were looking for like a low administrative overhead solution. We didn't want to be managing backups. We didn't want to worry about just building build slaves and kind of having to manage like a CI and configuration management infrastructure to kind of keep those going. We definitely needed the GitHub integration, and I think this was about the time of like Docker 1.3. Docker integration was still not first class and everything just yet. So we looked around at various tools. CircleCI just sort of announced kind of their Docker Jenkins. We had originally been using Travis early on, which had a complicated deploy to Amazon approach that just worked, but it was a little brittle. And then Drone had come out too about that time. And so after kind of looking at them, we decided to pick Drone. It's built around Docker, and it's got some neat functionality out of the box, just being able to snap in your dependencies by linking containers. Its state is completely stored in a database, so we were able to leverage Google Cloud SQL to keep the state of our builds and just everything kind of there. That works really great. It manages backups and everything. Unless it gets disconnected from the compute engine, but that's only happened a couple times. It's a single container deployment, so it was built with Docker and then deploys with Docker, and you just give it the Docker socket on the host it's running on, and you're pretty much good to go. And it really has that simple GitHub integration experience. You log in with OAuth from GitHub, or I think they support a few others. It has a list of your repos, and you click on, and it wires up the webhooks, and it does a good job of, the job definitions actually kept with your code, which I think is a really good paradigm. There's no like configuration on the drone server really, save a few secret environment variables or something. And so this is kind of the pipeline view that we ended up. That's cool. I didn't realize the clock was animated. The pipeline we ended up coming up with is pretty classical. Developer pushes code to the code repository, a webhook fires off and kicks off a build on drone. The status of the build is then updated via the status API at GitHub. And then we have a set of, since we have a lot of projects, a lot of different microservices to kind of test it out all at once, what we decided to do was build a special container that periodically rebuilds every day against the master branches of all of our microservices, and then it then kicks off a test run that runs against them twice a day, and then lets us know how they're doing. And it deploys out to a fully functional, long-running environment that has multiple nodes, and it's where we actually test, networking and authorization and everything else. So, this year has been pretty exciting. The number of developers has really increased. We've gone from, I think I was one of the first couple employees to 25 people, and it really started getting, as everyone ramped up, the build frequency, also went with it. We had built, a really beefy single server in Google to deploy our initial environment. But it's got multiple projects. We have open source pull requests coming in, and basically, a couple times a day I'd hear that drone is slow, or it would uncover some interesting timing issues just due to kind of being under load. So we needed to kind of address the single server solution. And about the time just before beta, as we were really ramping up into it. Rancher was mature enough with the private networking, the native Docker experience, to basically launch drone without really making any modifications and exposing, distributed build slaves to the system. And so we accomplished that today is something I'm going to be showing you. And I want to show you a couple different projects that, different types of builds that, we can run with the system, where one, you snap in dependencies like a Redis server during the build so that you can test against Redis, kind of doing validation tests. And then another is where it builds and then uses, pushes to the Docker Hub registry and then uses Rancher Compose to deploy the environment to Rancher. So, demo. Joe. And so we've got. Can everyone see this? Is it big enough?
Yeah, it looks fine. You can maybe make it a little bit over to the right, go a little bit of your screen, so you can show both of those if you want.
Oh yeah.
There you go.
Cool. Thanks. So here we just have a Rancher environment. It's a standard 3-node deployment for us. And what I've done here is labeled each of the hosts with a role. This one's going to be a follower, this one will be a follower, and this will be a leader. This is important because making scheduling decisions, I kind of need to know where the master is going to end up, so I can tell the GitHub target where to go for OAuth and tell users where to go for their drone and all the webhooks. So that's kind of why we've picked out these hosts in this way. And so come over to the console, and here I've got a Rancher Compose file, or Docker Compose file that I'm going to run against this environment. And did I not spin 3 times for the demo? Well, that's fun. Oh, I know, my keyboard was disconnected. I have.
I think that's the first. We've had Darren's in the last 2 meetups. We've had Darren's laptop crash at different times, but keyboard not connected is pretty good.
Well, yeah, I had it plugged into my other monitor, and normally I just use that, but I want to make sure everything is on the screen. So
awesome.
Now with the right keyboard, bringing up this environment, we see the container starting to spin up, and we'll go to the application view, and you can see the services that are coming up.
So just to be real clear, this drone compose file, you built that yourself. That's your combination of drone as well as these different services. Did you show that file, or could you pull up that file, or are you going to show it?
Yeah, I was going to show it in this view here, just because I think
okay.
that will make it a little easier to use. But so what I'll show here is here's the actual config file. I'll be removing these secrets later. But what we're doing is we have a service called volume cleanup that actually the graph view might be a little better, and then we can go through that file. So we've got the drone leader, which is the actual drone server here, and then we've got its database, and it's stored in a container. And then we have the drone followers. And so the cool thing about these drone followers is it's using this Docker SoCat image that we've got, which is a small Alpine Linux image that just uses SoCat to expose the Docker Unix socket over a TCP port over Rancher's private networking. So that allows us to securely expose Docker without exposing it over the broader internet. So it never actually is exposed out to the open. And so that's been pretty cool. Feature to play with for just different things, but this is one of the things we're using it for here. And then the drone leader is just a standard drone container. We've done a little lightweight wrapper around how it starts up. I can show you that. And then over here, we just have this other service that we run called Volume Cleanup. Basically, we do a lot of Python builds, so we build in Docker volumes, and so they get kind of large. You can't do a hard link with talks, so in AUFS. So we ended up filling up disks pretty quickly. So we have this that runs, and it just deletes the orphans after each of the runs. So yeah, here's the infrastructure. You can see.
Darren, I'm sorry, Darren. Bill, you in that template, in your compose file, I saw you had a bunch of scheduling policies there. It looks like you're using sort of global scheduling and then tags to sort of define how, where you place these different things in your cluster as your cluster expands. Can you talk about that for just a minute and sort of maybe on your, on specific, how on the different tiers of the application you're scheduling them?
Yeah, absolutely. So a lot of these we just want a single container to run, and we didn't want multiple. We don't want to expose the Docker daemon multiple times, and we didn't want volume cleanups to run across, have multiple, running against the same set of directories. So we're using this global the scheduling rules to kind of enforce those policies. So what we wanted was a follower here, like we wanted a global on any host that has the drone role follower. So if you add a new node without any labels, we won't put anything on it. But if you give it this follower role, Rancher will immediately schedule on it. And then this is the role on the container, which helps us set up the the anti-infinity affinity rule, so that if one is already running on the host and for some reason it gets into some sort of weird state where the service would try and maybe apply another one, it won't do that now. And so this is trying to enforce that one and only one. And so we've taken that same approach on the followers and on the volume cleanup, and then the drone leader, we just need a single one, and it needs to be on the host that we sort of want to land it in a specific space so that we can focus it on. Basically, we can target it from other services.
Awesome. There was a question that just came in, Bill, from Simone Potenza, and he was asking if we have docs where to find all of the different io.rancher supported labels. I don't know if you want to just talk about that briefly.
I can answer that.
Go ahead, Darren.
We have a PR in right now to our docs, so I think it will be merged today. But this has come up quite a bit, because we keep adding more and more labels. So we do have a reference now. I can actually make sure it is merged before the end of the day. It'll be there.
Awesome. If you get that, or you have a URL for that, can you just send it out in the chat to people who are attending?
Sure.
Yeah.
I will do that right now.
Awesome. Thanks. Okay, go ahead, Bill. Sorry, we've kind of cut you off with questions, but
no,
keep it going.
Great. Cool. So because we were able to target a specific host, we know that the drone master is running on the one followed by the leader, so we'll go to that host IP address. It was set up with authorization keys, and so now I'll start with the first demo. That keyboard's still not connected.
Hey, Bill, while you're pulling all this up, I mean, one question that came in was this compose template that you just showed. Is that something that you can share for if people want to recreate this in their own Docker or their own Rancher environments, or locally if they want to run just the Docker compose file? Do Can you share that? Is that
Yeah.
something you're okay sharing?
Yeah, I was actually hoping to have it done before this and include the link, but hopefully we can. I'll do it after the meetup, and we can send out the URLs. We'll make it a project on the Rancher GitHub repo, but you'll be able to download this and add your own GitHub credentials, and you'll have a running instance of Drone. Yeah, absolutely.
Cool. And could you also include details on the SOCAT container? Michael Dyer and I think Jacob Kristen were both kind of asking more questions about that.
Yeah, that repo is actually, I think it's on GitHub right now. It's Rancher Docker SOCAT, I think is the repo for that. You can look at the source, and we're happy to go through any conversations there. It's really pretty simple, but pretty awesome.
Great.
And if you have any questions, just open up issues or reach out. Happy to answer. So this is the Cloud.T Ready Go image, and this is Drone. You just find it, click Activate, and now it is wired up webhooks for us. And so this one is the Ready Go. Can everyone see this okay?
Yeah, it's coming through fine.
Great. So this is a Drone YAML file. It's basically defines what the build process will be. And just to kind of walk through it a little bit, it's specifying that we're going to use the Go 1.3 Docker image to build this, the Git path, the script, the actual build steps to follow. It's going to go into the Redis directory. We're going to go build, and go test. And I added a sleep 60 so that we can take a look at what the environment is like while this is running. It's a pretty fast build. And here is the services section, and what we're saying is we want a library of Redis, the image version 2.820, and what this will do is at runtime it will deploy the build container and also link in this service container using Docker links, so that you'll be able to have a Redis server available to you during your build. So just to make a quick change, we're going to add some enthusiasm to this README here, just to add enthusiasm. I should have picked an easier word to spell. Push master. So now we push it to GitHub master, and we can see here that the build is pretty much immediately firing off. And so what it's doing now is pulling down the image and building it. And we should see in a moment, once that happens, everything happening. Kind of a cool thing with this is, with Rancher, you can get the logs of the container, and we can see that it's actually pulling down the image right now. I'm wondering if you were wondering what was happening, and you can see that it's pulling down the Go. So it's still doing that.
Hey, Bill, while it's doing that, there's just a question about, just to kind of finish up on that SOCAT thing, is it actually the Rancher/SOCAT-test repository? That's where you have it in?
Oh, yeah, that sounds like it.
Okay. I'll send out the link.
Okay. Yeah, it's this one. Mm-hmm. So you can see actually here we've got one of the containers running on this host, so the build will be getting performed over here. This is the Redis server container. You can see the logs that it started up. Now it's going to be pulling in the build container probably. One of the cool things is as it's building, you can kind of get the real-time stats from kind of a Rancher function. You can see what's going on a bit there.
And Bill, while that's building, I mean, if you wanted to add additional capacity, I mean, you're showing this environment right now has 3 hosts, but if you were going to scale up the capacity and wanted to add more followers or something, you know, how would you do that right now? What's the, you know, maybe you could just walk through the cloning or the add host approach if you were gonna use just random integration to do that.
Yeah, so if you wanted to add another host, you would go through the add host wizard, and then you can pick DigitalOcean, Amazon EC2, Exascale, you know, wherever it kind of works for you. Add the hosts, and then you would be able to add a label as you're provisioning the host. If you wanted another follower, you would add the drone role equals to follower, and then when that came up, we would schedule a new container. To get that actually added to the master as a worker in the current version of drone, you would need to restart it. The way we're populating the workers is through the DNS entry for followers, and so it needs to read that. That part's not dynamic, but hopefully Brad has some cool things to talk about in that regard later on. So you can see that the build ran while we were talking, and you can see the containers that were there. It's sleeping, and so you can see that it had this goofy Heisenberg, and here's the actual build. Cool thing about Rancher is you can see, you know, kind of get access to the container. Interestingly, during the build, you can actually drop into a shell of the running image container for troubleshooting sometimes if you want to sleep in it, you know, just because something's not working right in the build environment, although those issues are definitely less with Docker. They still crop up from time to time. And so, you know, once the build's done, you can see that those containers are in here, and they're now, you know, they've been removed and garbage collected. So that's one approach of being able to run a build and then, you know, bring in dependencies like a database, kind of at build time, and to run your validation tests. And so the other approach that we're going to take is
there was a question there before you jump forward, Bill. Oliver, or Olivier, sorry, Robert asked, what's the drone image used here?
So we're using Rancher drone as the, sorry, we're using Rancher drone, or it's actually under, the image is Rancher drone-sd. The repo is currently in my Cloud Nautique. I'm going to need to move it over to Rancher. I was going to do that also before this, but I didn't get around to it. But we'll move that over to the Rancher organization so that it's a little easier to find. It's basically a standard, we just fork the repo and go ahead. No,
I was just going to say, why don't we put together all of these links and we'll send them out in the email that follows up for everyone who attended. Or
I was happy to do that.
Something.
Yeah, because yeah, absolutely. So, okay, this one, you know, I just made a minor change to the CI script. It's the Let's Chat app, and this one is going to run through its build, then do a Docker push to the registry, and then deploy it using Rancher Compose. So let's get the build started here. You can follow this along. It's pulling, you know, porting this over to use drone. The build script is, this one's configured a little differently. We're using a Docker and Docker container to do the build, just because we need Docker to actually build this. So we use the privileged container with Docker and Docker inside it, and we've been using that for a lot of our stuff, which is another reason we end up with large images filling up our disk, and kind of reiterates the need for having the volume cleanup. And so this is just going through and building. And while it's doing that, do we have any other questions? Just takes a
Yeah, there was another question that came. Before we jump to that, though, I just want to kind of acknowledge we're right around an hour in, guys. I know a lot of people have to leave. Maybe they have another meeting scheduled, and they only booked an hour to attend. We're going to record everything. I think I already said that. We'll send out things. So if you do need to drop off, certainly understand. We'll be sending out links so you can follow along and watch the rest of this later. Okay, yeah. So the one, I think there was just some person asked to clarify here. So when another host gets created in this cluster, this is Mohammed's question. He was saying, how does Rancher know to set up that additional drone environment on that host? Like, what's actually triggering that? Maybe I think you talked about the scheduling, but maybe worth just covering that one more time, maybe.
Yeah. Cool. So the kind of the way our service management works, it has a couple different scheduling policies, and one of them is global, which basically is saying I want one of these on everywhere, and that's just kind of what it's trying to do. And then you can put constraints on that. So when you apply, so we said in this particular case we want the scheduler to be global, and we want it to be on hosts that have this drone.role is equal to follower. And so whenever a new host is deployed with that label, Rancher is sort of aware of that, and then the service has a hook to look at it and say, okay, new host with this, it doesn't have this container or a container with this follower label, so I'm going to schedule one for deployment on there now. And so what we're doing with the followers here is linking that to the leader. So we have just kind of a normal link that you would describe in a normal Docker Compose file. And we're saying, link the drone follower service as followers. So like for what that looks like in Rancher is that we end up with a DNS entry, and I can show you, I think. So now if I do a dig followers inside the container, I get an IP address to the workers. And so when you would add another host and it scheduled that container, that next dig would give me that additional information. And so the way drone currently.
Bill, are you showing that? Sorry, are you showing that or just discuss? Sorry, I didn't see your screen move. So, were you trying to show something else, or are you still showing the container?
Do you see the? No, I'm showing inside a shell. You don't see that?
Oh, it took, at least for me, it took a second for it to load. Now I see the shell. Sorry.
Okay. So what I did was I dropped into a shell on the drone leader container and did a dig for the followers, which is how we told Docker or Rancher to link this container to these two services together. And so Rancher creates a DNS entry for this container so that followers returns all of the other containers, all the container IP addresses of that service. So it's a pretty cool feature.
And so really what's working behind the themes there is it's really a combination of networking. So Rancher implements a private network between all the containers, and all the containers get these private IP addresses, which you can see there in the 1042 space, as well as service discovery, which basically tells the system, this is a drone, drone leader, here are the IPs for all of your drone followers. So that's where that link enables, the service discovery that you define inside Compose and within Rancher to turn that into an actual relationship in the network.
Mm-hmm.
Right, Bill? Yeah. So another question came in. There were a couple questions about drone. It looks like the first question was how does drone display generated Java docs, coverage reports, unit test results, etc. And if you don't want to jump into that too much, we can also sort of leave that question for Brad. But if you want to discuss that, that'd be great. And then the other question was, how does drone prevent containers from overutilizing resources and crashing the CI system?
Yeah, I think some of those might be best answered by Brad. The way that you schedule out builds, at least what we're using right now, and I think Brad can talk about more what type of Docker options you can add. I think they've been working on some of those configuration settings. But what we do is basically build slots per host. We roughly look at how much capacity each build's usually taking, and just kind of give it slots based on that. We typically run at about 2 slots per host, but you could try and lock it down. I mean, typically, in my experience with build systems, developers want things to move as quickly as possible and really don't like being throttled. So if the slots model kind of enforces minimums in the crudest way, but Brad might have some more insights onto some good approaches there.
Awesome.
I swear this worked last night. What? I didn't change anything.
So what happened there? What the build you ran a second ago failed?
Yeah. Curl get tar lm install that Discompose. Do I remove where it was copying? Let's try Docker compose .yaml to dist. Give that a shot. I swear this had worked before.
So here you're basically just pushing an update to this new Let's Chat instance, which anyone who attended last week, we were playing with Let's Chat as well. It's a really fun application to use in these example setups. So now you're rebuilding it again, pointing it to a different directory for the output?
Yeah, so I believe what the script had been doing was it was in there is this Docker directory, and within the Docker directory is a Docker Compose YAML file, and at some point in this script last night, it was doing a copy of that file to dist, and then later on what I'm doing here is basically substituting app image, just all in bold, with the name of the image that we specified up here for the actual build. And so we're building, Cloud.NT, Let's Chat, and then versioning it with the drone build number, exporting that so that we can use the variable substitution down here, and then hopefully deploy it. That's ultimately the goal there.
So there's a question that came in from Olivier.
Yep. Do you want me to cover the coverage report question while the build's running?
Yeah, that'd be great.
Yeah, sure. That'd be great.
So, in terms of coverage report, artifacts, Drone works a little bit differently than maybe traditional systems like Jenkins that stores all of its data into Jenkins. So instead of being more of a big monolithic application, Drone has plugins that let you easily interface with external systems. So if you wanted to use or publish your coverage reports, for example, you could use the Coveralls plugin, which would publish to the Coveralls service. Or if you have large downloads or artifacts, you can use the bin tray plugin to publish to bin tray, or the S3 plugin to publish to S3. Now, in some cases, you may not want to you publishing your artifacts or your reports to cloud services. And so instead of building that functionality into Drone, what we're doing is under the Drone umbrella, we're going to be launching microservices. So you can run Drone, and then you can also run the Drone coverage report system. So they'll be tightly coupled, but it'll treat it more of a microservices architecture instead of bundling everything into one giant monolithical application, which is kind of how I would describe Jenkins, and not necessarily in a negative way. So you will be able to self-host document or artifact management or coverage reports with Drone, but it'll just be done slightly differently than with something like Jenkins.
Awesome. Thanks, Brett. That's helpful. And Bill, as this is building out, once this is done, what's the next step in your demo? What are we going to look at once we have this image finished?
It's pushing the image now. Yeah, it's pushing the image now, and we'll know in a second if it did the right thing there. And basically, we'll be able to see that this service is now deployed. We could just look at that real quick, and then that would be kind of the end there.
And will it push are you actually pushing it as an image to Docker Hub?
Yeah, right now you can see it's pushing Cloud Nautique, Let's Chat, build 2.
And it's
so
pushing to your private Docker Hub. There's your Docker repository there.
Yep, that's to my user account on Docker Hub.
Okay.
All right. So Rancher Compose is now bringing this environment up, and so we should be able to see here's the Let's Chat app. It's starting to deploy. Well, let's go look at the services view. You can see that I've got a new service, Let's Chat. It's bringing up the Mongo piece right now.
So basically, it's triggering the trigger for finishing the build is triggering a compose run against Rancher to set up a test environment. Correct?
Yeah. Yep. And it looks like it's having some trouble. I'm guessing insufficient disk space. Yeah. So let's see. That's trying to go on that. I'm going to log into the host and see if I can free up some space. Mongo apparently likes its disk space.
This is one of the reasons just in terms of the size of images tends to be something you really need to deal with clean up your script you're saying before, constantly removing these things because they do kind of fill up the disks if you're not, running with large disks on your hosts.
Yeah, I think kind of as a best practice, like when you're running in your build environment, like your deploy environment, I can either see not having specific hosts that weren't necessarily tied directly to the build system itself. So like here, all the build images and everything, and then I'm trying to deploy in another set of containers on top of it. It looks like I freed up enough space here so looks like it started up. So we can see that this came up now, it ran out of disk. And then now that that's coming up, this service should go to activated, and we should bring up the
actual app server itself.
Yep, and here comes the app server. Yep. And so now you can see that, I keep clicking the wrong button. Here's the config that was deployed, and here's how they're linked, and this is coming into activating. So you can now, from a drone build, you can actually deploy your application into another environment and get a green build that it actually was able to deploy that.
And then run some integration tests, whatever integration test you might have that you want to test against that deployed build.
Yeah, you could
awesome.
Yeah.
There's a question that someone came in. Is there any reason this wouldn't work with Jenkins or other things? I think the answer is no, absolutely. I mean, conceptually, your CI system, there's certainly advantages we found in Drone because it's designed for containers from the ground up, and Brad will talk a little bit more about that. But if you use Jenkins or you use Bamboo, conceptually, you're doing the same types of things.
Yeah, and I think kind of the cool, neat thing about kind of deploying on the Rancher is just how you don't ever have to actually expose Docker to the internet if you don't really want to, and I think that's kind of compelling, and it's really easy to discover. But no, you could do this with Jenkins or any of the others. Yep.
Awesome. All right. Well, Bill, anything else you want to cover? I think that was really useful and helpful. Hopefully it answered lots of questions. If people have more questions for Bill, he's not going anywhere. He'll be around the rest of the time. But now I think it's time to turn it over to Brad to kind of drive into the details of Drone. So, Brad, I'm going to make you the presenter. Give me 1 second.
All right.
Let me know if you get the little thing that says share your screen. You should be able to now. Beautiful.
All right. Can
okay.
you see my screen?
I see it. Yep, you're up and running.
All right. Trying to figure out how to hide this webinar control panel. All right, there we go. Still see it?
It hides itself. Don't worry.
Okay. All right. So I just wanted to talk to you. Everyone saw a version of Drone and how you can use that to run your builds and automate your deployments. And I wanted to just talk a little bit about what's coming up in the next major release of the Drone project. And that's been in progress for a few months. We've had a lot of people using Drone and gathering a lot of feedback, and I wanted to talk about that today. And I really wanted to start with some of the problems that we see people have that they want to solve with their CI system and how we're addressing this in the upcoming release. So problems that people face, they want to run their test suites in parallel so that their builds are faster. They want to test code against multiple languages. Maybe they want to run their Node code, their front-end code, and their back-end code, maybe Java, in parallel to make their tests faster. Maybe they want to test their code against multiple language versions. They want to test against Node, and maybe they want to test against the newest version of IO.js. They want to test against multiple databases. Maybe you're using an ORM and you want to test against Postgres and MySQL. Or maybe you want to test against multiple database versions. You want to test against Postgres 9.2 and Postgres 9.4. And so the solution to this problem is matrix builds, and that's one of the biggest changes that we're making in this upcoming 0.4 release, is it gives you the ability to test your code against multiple environment configurations. So let's say we have a simple Drone YAML script. We're testing, we have a Go project. We're testing it against Go version 1.4, and we're testing it against Redis version 2.8. What happens if I want to test against multiple versions of Go or multiple versions of Redis? And to do that, we've added a matrix section to the YAML. So if you look down here in the matrix section, you can see we define two different variables: Go version, which can be 1.4 or 1.3, and Redis version, which can be 2.8 and latest. And then up above in the build and compose section, we inject those variables in using a kind of like an old school makefile environment syntax. And what this is going to do is it's going to actually end up building 4 different permutations. It's going to test our code against Go version 1.4 and Redis 2.8, Go version 1.3 and Redis 2.8, Go version 1.4 and the latest version of Redis, and you get the point. And so this is just one way we can parallelize our tests. We can execute our tests against multiple environments, and it's probably our most requested feature. The second problem that we face, or that we have hear from our users, is people want to customize drones.
Hey, Brad, before you jump on, there was a question. Hey, Brad, there's a question on that matrix topic. He was asking if you could also do a matrix of images. For example, if you want, this is from Charlie Lewis. He wanted to say, could I test against Ubuntu 12.04, 13.04, 14.04?
Absolutely. So I think what's interesting about Drone's matrix implementation that sets it apart is it's purely a string find and replace. We parse out the matrix parameters, And then we do a string find and replace in the YAML for each permutation. So that means your matrix can be an image, a service, an environment variable, a tag, an image tag, really anything that can be found and replaced as a string, which is anything in the entire YAML, can make up your matrix. And so I think that makes it extremely flexible. There's really no limitations as to what the matrix can be made up of.
Can you run matrix jobs separately, someone asked? Or does it all have
Separately,
to be one run?
So
yeah, I don't have any more
them
context.
as separate build jobs. So you will give a demo of it, but you'll see them separately in the user interface.
Okay, great.
And so the second problem that we wanted to address is people want to customize Drone. They want to publish to some external service, S3, FinTray, Docker Hub. They want to deploy to some external service, Roku. Maybe they want to push to Rancher. They want to message their coworker in an angry cat meme every time they break the build. They want small Docker images. They don't want monolithic build images. And the problem is when you want to do those above things as part of your build, you end up junking up your build image with a lot of stuff. And we actually saw that in Bill's demo, how it took a long time to download the build image because it's a big monolithic image, and people want small, targeted images. And really the problem is people need Drone to do something that it doesn't currently do. And the solution, this has kind of been around for a while. Jenkins does it very well. It's external plugins. So that's something we wanted to solve in the 0.4 release. But plugins have problems themselves. We're not quite in the clear, right? Plugins run untrusted code. Plugins aren't sandboxed. Plugins need to be installed by an admin. I'm sure there are people on the call that have needed something installed, and a week later, the Jenkins admin finally has time to do it, and meanwhile, you're sitting there blocked. And then what happens when you need to update your plugin? And plugins need to be written in Java if you're using Jenkins. Not everyone is running a Java shop. Maybe they want to use their language of choice. And so kind of the general takeaway is plugins should be safer, easier to create, and easier to publish. And so our revised solution is external Docker plugin. And so something I think interesting that Drone does is our plugin implementation, the container is the plugin. Plugins are Docker containers that are hosted in the index that are downloaded on the fly as part of your build and can link to your build container. They're sandboxed because they run in Docker containers. And so a plugin, if we're to look at the YAML, looks something like this. So we have our build, we're building build1.4, running some commands. And at the end, we say we want to have a notify step. And that notify step is we want to send a Slack notification, and we want it to be the Slack plugin image. And then we have below that some Slack-specific parameters. And what's going to effectively happen is when Drone is running this build, it's going to look for that plugin Slack image, and if it doesn't exist, it's going to Docker pull it. And so what's great about that is you don't have to ever ask someone to install or set up a plugin. You don't have to worry about the plugin running, untrusted code on your host machine. You don't have to worry about what language they're written in because they run as Docker images. And the way plugins work is they accept a structured input over standard in. So it effectively looks something like this. When Drone gets to the plugin step, it does a Docker run plugin Slack, and it sends in all the metadata about the build the plugin might need to execute its task. So the repository information, the build information, and then this arg section at the bottom are the arguments from the YAML that were specific to that plugin itself. And so because this is coming over standard in, that means your plugin can literally be written in any language that you want. As long as Drone can pull it from an index and execute it, it can receive this data, it can parse it, and it can do something with it. So it's a pretty flexible plugin model. We're really excited about that. And so because this is coming in the upcoming version, I wanted to prove that this just all isn't vaporware and it actually works. And so I thought I would do a quick live demo. And so what you're looking at on my screen is the upcoming 0.4 release of Drone. And I have the same Redis project that Bill built earlier, and I have my fork here in GitHub, and I have my YAML file, and you can see here I have it set up to use a single Go version and a single Redis version. But I would actually like to run this as a matrix build. And so if you look here in the drone user interface, you can see right now we only have it running, Go version 1.3. And so what we're going to do is we're going to edit the YAML file to run a matrix build. So I'm going into here, into GitHub. I'm declaring the matrix section. Then I'm going to say Go version. And let's do Go version 1.42 and 1.3.2. And let's try Redis 2.8. And let's do the latest tag. And then so now we need to go up here, specify the Go version, go down here, and specify Redis version so that it can inject everything appropriately. And now, if I did not make a typo, added matrix build YAML, commit the change. We can see this running. Now we can see immediately it starts running the build, and on the left-hand side we see each permutation of the YAML, and you can see as it's going through, it's executing each different permutation here. So we can click on the Go 1.3 and Redis 2.8 version, and it looks like it's waiting on the Git checkout step here. Hopefully that'll finish. All right. There it goes. All right. So there we go. So we ran through, we executed a matrix build. We ran 4 different builds. We tested the Redis library against 2 different versions of Go and 2 different versions of Redis pretty quickly, minus the Git clone hanging there for a few seconds. And we can easily just kind of restart this and start the whole process over again, and we can see it running. And hopefully it runs much faster because it doesn't hang and trying to connect to GitHub. But so you kind of get the point as to how this works, how easy it is to get up and running, and hopefully something that under the covers is actually quite complex, looks really simple. And so I wanted to just jump back into the slide and talk about a little bit more what happened here. So Drone under the covers does essentially container orchestration that's specific to your build. And so when Drone receives a hook from GitHub, and we process that hook, we grab a YAML file and we figure out, we get all the build configuration data. The first thing we do is we deploy an agent container. So Drone doesn't have an agent that you have to put on your remote servers like you might have to do with something like Jenkins. For Drone, it just connects to Docker daemons using the remote API. And so for every build, it'll just automatically deploy an agent just for that build. That agent then is going to spin up a Git clone container. It's a plugin. So everything that's happening in that YAML is now a plugin. So that means you don't actually even need Git in your main build container because that's happening as a plugin. So the Git clone container launches, it clones your code. Then we have an environment preparation plugin. That plugin is going to do things like set up your build script, make sure you have environment variables, make sure certain keys are installed. Then the agent goes ahead and launches the Redis container that we specified in the compose. It also launches the build container and runs our build commands. And then at the end, if we configure something like Slack for notifications, it runs the Slack container. So what's interesting about this in the 0.4 version is that this single build ran 6 containers just for one build, all orchestrating together to perform a task. And since this was a matrix build and had 4 different axes, in that 45-second demo, we actually created and destroyed 24 containers as part of the process, and it executed very quickly and hopefully seemed pretty seamless. And so, in a nutshell, that's some of the stuff we're excited for in the 0.4 release. It's coming soon, probably in September, but we'll have an alpha cut that people can download and start playing with this month.
Awesome,
Then
Brad, that's fantastic. There was oh, go ahead, there was just one, go ahead, feel free.
Yeah.
Go ahead, Brad, sorry, I didn't mean to cut you off.
Oh, well, I wanted to, someone asked, could you do this in Jenkins? And someone asked, how does Rancher differ from Compose? So I added a last-minute slide, why drone? And I thought I could walk through some of the bullet points about what in some of the systems out there. But before I go into that, if you want, I can take a question. Maybe they're related.
Yeah, there was one more question. Well, there was actually 3 questions, so I'll just hit you with a couple of these. One was, can you selectively rerun one of those builds from the UI, or do you have to kind of submit a new YAML file, like if one failed for some reason?
So, yeah, so you want to re-execute just one job.
Yeah, exactly.
So it's not hooked up, but definitely something that we'll add in the future. It's still a young project. I'll kind of remind people, even if it kind of looks polished, it's still a young project, and so those types of features are things we'll add, especially if people go into the drone issue tracker and request features. We use that to kind of prioritize what we work on.
Cool. And then there was another question: is drone is open source? Are all of these features available in an open source version, or is there 2 versions? Can you just talk about which versions? Maybe you can talk about that on this wide drone. I think the other question was about, is there an API? So maybe you can cover all that.
Yeah. Okay. So everything you just saw right now is open source. Open build demo and my demo. All the plugins are open source. They're and let me just jump out of this. So we have a drone plugin organization, and this is where we're starting to add plugins for the 0.4 release. So the 0.4 release, right, it's still playing catch up. We're still porting plugins to this new model. So we only have a few, but that number will grow. And then we also we're working on kind of a marketplace where everyone can publish their plugins to, and we'll do a fun contest for plugin contest for some prizes and stuff too going forward. The drone project you can find at github.com/drone/drone, and all the work we're doing for the next 0.4 version is available in these 0.4 related branches. So if you're brave, you can definitely go in and run exactly what I was running today. And then the second question regarding the API is, yes, we do have an API. So this is the API. There's a Swagger file available, and we kind of auto-generated all this. But Drone uses Angular for the UI, and that means pretty much anything you saw in the UI that you could do is available as an API endpoint. So you can definitely easily integrate with Drone, build dashboards on top of it, all kinds of cool stuff.
Awesome. Excellent. Do you want to go through the last why drone slide maybe, and then?
Yeah, so I kind of want to talk about why drone and what makes it different from some of the other CI systems out there. So it was mentioned earlier how you guys kind of started with Travis and how it was a bit difficult to install and flaky. Drone is meant to be installed. Travis is an awesome system, and we've taken a lot of great ideas from what they've done. But Travis was built to be a cloud service. Drone was built to be installed on your own hardware. So it's literally a single binary install. It's written in Go. So you don't need to install anything, and it has 0 dependencies. You download the binary, and you're good to go. It's lightweight with a low memory footprint, so it can run on the smallest $5 DigitalOcean box, and you're still going to have plenty of system resources to do other things. The builds run in Docker containers. This means you never have to install Node or install MySQL or set up a build environment like you do traditionally. It also means your developers own their build environment. They can specify their containers, the tools that are in their containers, those types of things. Build images are auto-downloaded. Plugins run in containers, so you have that extra layer of safety. You can build your own plugins in any language you want, and plugins are auto-downloaded. You don't have to ask someone to install them. You have a simple YAML configuration that sits in the repository, so when your build changes, it's part of your Git commit history. We do matrix builds. Drone supports any language that can run in a Docker container. So that means it's never going to dictate what languages you can or can use with the system. Any image that's on the index, any of the hundreds of thousands of images you can use as your build environment. If you need a Go image, that's in the Docker index. If you need a Rust image, that's in the Docker index. And as Microsoft launches support for Docker on Windows, you'll be able to use Drone to build your C# or Windows applications. And Docker's running on Solaris now and OpenBSD. So, Drone will effectively, through Docker, become a multi-operating system build environment. And then additionally, and this is kind of a big deal, if you're coming from the Travis world, Drone supports GitHub. It also supports GitLab, Bitbucket, Dogs, and a variety of tools. And if we don't support the version control system, you can add it. And so I think of Drone as kind of like a best of both worlds between, Travis, which is a great modern cloud hosting system, and Jenkins, which is one of the most popular on-premise. Drone is a great mix of the two, but it's built for Docker, and everything it's doing is trying to use containers in innovative ways to improve continuous delivery. So that's kind of my spiel about Drone.
Awesome, Brad. Well, thank you so much for this project. I think I know we appreciate it a ton, and it makes our lives a lot easier all the time. So thank you, and I certainly encourage everyone to visit drone.io, check out the the project, give it a spin up. It's really easy to get started. I mean, that's one of the coolest things about Drone. Okay, so just pulling up sort of kind of the last couple things we wanted to discuss today. Screen. Okay, hopefully everyone can see my screen. So we wanted to talk, there's a number of questions that came in about Rancher that I sort of decided to push towards the end, so happy to answer those. But we also wanted to spend just a couple minutes at the end of the session talking about some of the latest enhancements for those of you who are using Rancher. If you're new to Rancher, Rancher is in beta. It's also open source software. You can download it just by visiting our GitHub site or just going to rancher.com. You can find it. But it's also just a single container to get that up and started using Rancher in your team. The platform does a lot of stuff, but we made a bunch of enhancements recently to some of the networking functions and service discovery capabilities. Darren, if you're there, do you want to maybe talk through some of the changes since the last meeting? This is something we're going to try and do every month now, guys. Just we'll push some of this to the end of this session. If you want to get the latest on something, or if you have Rancher questions you want answered, we'll stick around and answer those as we go. Go ahead, Darren.
Yeah. So a lot of enhancements to load balancer. We're constantly adding more and more features. There's actually a lot of neat features being released next week too. But what is currently in the latest release, what we just added, the first one is the virtual host support, which is one of the biggest requested features for load balancer. And this is basically hostname and path-based routing. So I can set up one load balancer, but based on different host names, forward it to different applications. And this is really important when you're running like a smaller deployment and you only have so many IPs. Before what we had, basically you'd have to run one load balancer per public IP. Now you can reuse that public IP and load balance a series of different services. And you can also do the routing based on a path, not just the host name. So the second thing we added was the labels and scheduling for the load balancer. We've always had this in the back end, but we added it to the UI. What this means is when you scale up our load balancer, you can say, I want like 5 instances of this. you probably want to designate specific machines you want to run it on, because those are the ones you configure the IPs and the round robin DNS or things like that. And so you want to have specific scheduling rules for your load balancer. Internal load balancing. This is just the ability to create a load balancer between two applications that's not published out to the internet. So it just runs on the private network. This is great, for between tiers of your application or various microservices. Load balancing external services. So there's quite a few changes to external. What external services are is when you have when you look at linking containers together. Maybe in my Docker Compose file, I've linked a container to MySQL, and that's great on my desktop or in development. But when I go out to production, I really want to use or I have some other team managing MySQL. And so what we've done with external services is the ability to override that part of your Compose file and just say, okay, I actually want this to point to this IP. And then what we recently added is the ability to just point to a different host name. So it's basically a CNAME for that service. And then we can also load balance those external services. And so if you want to set up one of our load balancers, but you're not actually load balancing containers, but you're just load balancing other things, that works. You just want to leverage our load balancer. In terms of service discovery, we now support cross-stack linking. Kind of in a Docker Compose file, you link containers together, but there's one section for external links, and we've basically overloaded the concept of external links to be able to point that to a service that might not be within that stack. And so this works out great. Let's say in the virtual host load balancing situation, you can have like 5 different apps and 5 stacks, and then you can spin up a stack just for your load balancer and then load balance to the apps across different stacks. Or someone can create a stack and then expose the service that other stacks can consume. Service sidekicks. This is just, we've had this support for a while, but we're kind of slowly rolling out in the CLI and the UI because it's a little bit more a feature. A lot of users really like this, but we're just making sure we get the user experience right. But the core feature of this is when you deploy a container, you want another container to always be right next to it. And this works great for, like, let's say you spin up an Nginx container and do an SSL termination, or you want to spin up like a Logstash container and do log indexing. Or the common use case seems to be, I want to run this other program that adds services, or some monitoring capabilities to my application. Or you might have an application that needs to communicate to each other through files on a disk or IPC, things like that. And so we support that. And the last major feature is going to be the rolling upgrades. This is basically you can have one version of a service, and then you deploy a new version of that service, and then you can say, okay, now upgrade this service, and I want to do it rolling on this interval, and I want to do like batches of 2 or 3 containers at a time. So it'll spin up 3 new containers, make sure the health checks all go green, and then it'll spin down 3 of the old ones. And then keep doing this process over and over again until eventually your whole, what you're running is the current version. And then if you want to, you can roll back, but rollback is really just an upgrade in the opposite direction. So this just a little bit of automation that we've added to make upgrades a little bit easier.
Hey, Darren, all of these are in.
Yeah.
Which version are these all now available in? The 0.30, 0.31? If they want to get access to this, what release should we be downloading?
Let me just double check on the exact. So it's going to be in 32, which is the current release. So if you just say Docker run Ranger server, that's what you're going to get.
Got it. And another question is in terms of the Docker version, will can people start using 1.8, or do they still need to stay at 1.7?
You can use 1.8. There's just one little side effect. There's one little tiny breaking change in 1.8 that Docker did that makes it so right now in the UI you don't see the Rancher agent containers. If you run 1.8 right now, you will see those containers. We don't ignore them because of a breaking API change, but that's being resolved in the release that's being put out this week.
Okay, so so maybe use 1.7 if you're testing it out today, but by next week use 1.8.
Yeah, you'll be for sure fine next week.
Awesome. And there was a couple other questions that do you want to finish on a couple things, and I'll let you finish up this slide, and then if you want to, we can ask. There's a couple questions that have come in.
I mean, no, there's just a couple other things at the bottom there. So basically, our DNS our DNS-based service discovery will now randomize responses. Before we were, basically relying on the client to kind of pick the right ones, but now we just randomize it. And then we've added improved server SSL support and actually multi-node support. So we've just cleaned up a lot of the things to make it, like if you want to do a real production grade deployment of Rancher with SSL, multi-node, quite a few enhancements and things have gone out there to make that much easier. And we're still working on a couple of those things, making it really easy to run like Rancher behind the ELB with proxy protocol and things like that.
Well, so let me go through. I'll go through a couple of questions here, and you feel free if you want to pull up a demo environment to show any of these things as well. Do you want me to make you the presenter, Darren?
Well, I mean, let's just go through and see if there's anything I want to show.
Okay. So one question from Andy was, can you explain how you manage secrets for the container configuration? We'll talk a little bit about secret management.
Yeah, so this is so basically what we have in Rancher right now is we don't have anything kind of specialized for Rancher in terms of secret management. Like this request is coming up quite a bit, and like I say, we will be providing a solution here. So basically the secrets management is kind of based off of what you can just find out in the community, in the Docker community, what people do. I'll tell you one of the solutions that's gaining a lot of traction, has a lot of popularity, is Vaults from HashiCorp. It's really flexible, provides a really good take on how to manage secrets, but it does require a little bit of plugging in Vault and maybe using CompT or other things to generate configuration. So we don't have anything specific for that, but it is a kind of a high priority request that's coming into us.
Awesome. And then this is a new, Michael Dyer was asking if you had any suggestions for setting up a 3-node sort of virtual lab environment with some persistent storage. I mean, we're maybe you can sort of we'll take that more generically. Just how do you recommend people get set up? Should they use Vagrant? Should they kind of put it on a cloud? What's a good place to get started setting up a Rancher environment?
Yeah, I mean, honestly, the easiest way to get going is just basically Docker run that starts up a Rancher server. We now support like blind mounting in the var lib MySQL directory, so you want to be able to kind of back that up manually or something like that. So we already run the database inside of there. You can externally link, but if you just want to get up and running, especially for development environments or a simple test environment, then the embedded MySQL is actually good enough. So just basically Docker run, and then the easiest thing to get going is use our built-in add host support, which will just go out to the cloud and grab some hosts for you. Typically, most people can get a Rancher environment up and running pretty quickly.
And if you have local resources, you have VMware locally, you can use any of those type of resources. Well, really, even physical boxes. When you have a lot of people who set their environment up with just a couple of hosts, you can deploy a Vagrant if you just want to run locally. I mean, there's lots of different ways. You can see a lot of getting started guides on GitHub or on our website in the docs. There's really good docs at if you just go visit rancher.com and you see a good getting started guide there.
You want to make me the presenter? I'll just show. Just really quickly, just in case other people haven't seen the kind of the add host.
Let me make you the presenter. Here we go. Sorry. Okay, you're the presenter now.
Show my
You can share your screen.
Okay. And how do I get rid of that? Okay, you should see me logging in right now.
So I just wanted to point out, because as I was saying, for adding resources, it is very easy. We can do this from the add host section, where we can just pull from a cloud, but really the most popular approach is this custom approach. And so anything you have, like internal, if you have some server provisioning framework, in your organization already, just copy this command and put it in, your equivalent of Cloud Init, or, in Puppet or Chef or something. When the server comes up, run this, it registers. In terms of, one of the questions did include like persistent storage. That's a big coming soon. We'll be doing a lot. Like in Docker 1.8, volumes are now out of experimental, and we hope in 1.9 some of the APIs will get more powerful. So you'll see better persistent storage management, in Rancher and in Docker coming.
There's a couple questions, just kind of questions about, is this cloud supported or that's cloud supported, GCE supported, why doesn't Linode get supported? Just to be clear, guys, these hosts, we talked about this in other meetups, but the 5, that are sort of here in the UI are just a subset of what's available in the API. So we support anything that has a Docker machine driver. So you can use GCE, you can use Azure, you can use VMware, and people are making pull requests all the time for new UI. So like Exascale just added their UI to Provision Rancher into Exascale, which is a European cloud hoster, last month, I think. So you can really pull up, you can deploy to anything that has a machine driver. Machine drivers aren't coming out all that fast. So Docker's got a lot of people submitting new machine drivers, and I think they're going through a lot of validation and trying to get them all working. So you can always make your own as well if you want to.
Yeah, and so we're this is kind of I want to close up. This is the API where we various things support: Amazon, Azure, DigitalOcean, OpenStack, Packet, SoftLayer, VirtualBox, VMware vCloud Air. So these are basically pretty much every plugin that is currently, every provider that's currently in Docker machine, I believe we support, except for GCE. But the status of these drivers to Docker machine right now is that they're looking at this plugin architecture such that people aren't kind of bottlenecked on the core Docker machine project, so people can release these plugins externally. And so we're working very closely on them to push that through. And so hopefully we'll see the ability to basically kind of like people can create their own plugins that will be specific to your organization, like because you have your own provisioning process that's based on some custom thing you might have, but you can create a Docker machine plugin and then upload it to Rancher and then be able to plug into your organization. So that's really our focus right now, is trying to get that plugin ability working.
Awesome. A couple other questions that came in over the course of the session that I was hoping to address. One of the one was Roman had 2 questions. One is sort of what's the future of persistent volumes? MySQL on host 1, moving database on host 2 on crash, things like that. Can you maybe talk a little bit about sort of what we're thinking there? And then the other question was about the scheduling. So I'll read that one after you're done talking about persistent volumes.
Yeah, so the persistent volumes is something we care very much. We've been working on some storage things for, I think it's probably one of the things we spent almost the most amount of effort is trying to address the storage issues. And so you will see, like our initial approach is basically just to be able to do efficient snapshots of data running on your server, if it's like on local disk or on EBS, or just be able to do efficient snapshots and back those up to an object store and then restore them to a different server. That's the initial phase of what we're trying to do, and we're working hard on that. We think we're pretty close to pushing out something there. So that's kind of really something to look forward to from us. A little further down the line is that we're looking at doing full mirrored replication. We have some pretty cool technology we're building in that area, but that's a little bit farther down the line.
Awesome. Then the next question was on scheduling. What's the roadmap for our scheduler? How does it compare to stuff such as, a Mesos' scheduler or Kubernetes or Swarm? And, how are we thinking about scheduling in Rancher?
Yeah, so I mean, I think our scheduling is you know, pretty good right now. We're seeing it's covering most use cases. I think the biggest gap right now is resource-based scheduling. So you say like, you know, this machine has 10 gigabytes of memory, and I want to give 1 gigabyte of memory to this application. So that's kind of the big hole right now is resource-based scheduling. And I can see that we will probably add that functionality because it's, I could see that, you know, coming in the future. But the thing is, we definitely, it's kind of like we don't want to get into a scheduling race here. We're not out to compete with all the schedulers out there. So our focus is a little bit more on how do we integrate these schedulers. And so there was recently, we did this great project with AT&T, what's the name of the labs there? I can't remember. But we did this work with AT&T around running Rancher with Mesos, so we can pull resources from a Mesos cluster. And so you'll see us, the future here is really, you know, we have our out-of-the-box scheduling. You know, we think it works pretty well. We'll probably continue to enhance that, but we know other people have other scheduling frameworks that they may have put a lot of effort into or have an investment in, and we really want to just be able to plug in those schedulers. So you can continue to use all the great like composition features or load balancing, all that stuff, but maybe you really, you know, build some cool things like into Mesos. And so we're looking at integrating those frameworks.
Awesome. All right, cool. I think that's, oh, actually, there's one more. Christoph had a question about networking. He just said, is there any known limitations on the number of Rancher hosts for the overlay network performance or anything like that?
Right. I mean, I wouldn't say there's specific like known limitations. What we know what the limit is. I would say what we're going through now, you know, we've been pumping out features, I mean, really fast, and we're really looking at spending a little bit more time on making sure that, you know, the product is rock solid performance, not, you know, really load testing it and do due diligence of, you know, making this you know, ready for GA. And so we will be going through that testing to figure out where the breaking points are. I can't really say, you know, we've seen, you know, I'm comfortable with saying, you know, if you're staying below, you know, 100, that would be fine. But beyond that, you're probably going to see some issues. It's not exactly the number of hosts; it's your change rate. It's really how quickly you're deploying new containers. But so I don't have a great clear answer, but that's like we're hoping to be able to really figure out where this breaks, and we want to scale really high. So we'll be putting effort into that.
Awesome. Hey, one last question is, you know, is kind of, I think it's something you can chat about real quickly coming soon, but are there any other, Andy asked, are there any other identity providers supported apart from GitHub, which is obviously what's only supported right now?
Yeah. So in terms of identity provider, the biggest one we get a request for is LDAP and AD, and that's coming very soon, very, very soon. I mean, that's basically, it's supposed to land in master. The back end is supposed to land in master today, if everything goes as according to plan. You know, we've been testing that out with some customers of ours, and so we're moving forward on the LDAP implementation, and then right after that, basically what we're looking at doing is local auth, because we have got quite a bit of requests that people just don't even want to integrate with a third-party thing. They just want a simple local authentication. And then after that is then we're looking at Bitbucket and OAuth. But for those people waiting for LDAP, I mean, it's coming very, very soon.
And so because AD would also be supported with that same thing, is like when someone asked if Azure AD was supported as well. Yeah. Okay.
You know, I'm not going to be like 100% confident on Azure AD, just because I know like Azure might be slightly different. So if there's issues, we'll address it. But I'm not totally sure like our QA is covered Azure AD. So yeah.
Great. Okay. All right, so I think that pretty much covers all the questions that came in. If anything else comes up, feel free to email us or tweet to us or anything else. We'll try to get back to you. Just as a reminder, Rancher's still in beta. If you haven't already signed up for the beta program, just visit info.rancher.com/beta or our homepage. You'll see a link to it, and join the program. We really the advantage of joining is you get some support and help if you run into any problems. You get access to an email to get support. And we always love feedback, so we tend to ask for feedback and reach out to people that are in the beta for feedback. If we haven't talked to you yet and you're in the beta, be sure that we will be at some point. So yeah, please join the beta. No cost. We're just looking for feedback and insights. Rancher's beta started about 2 months ago, so we're probably somewhere near halfway into the beta. Looking probably to GA sometime later this year. If you haven't been to see Rancher OS, and GitHub, you can find everything here, pull down the code, and have access to the projects. Otherwise, thank you all very much. Brad, thank you for joining us as a guest. Bill, thanks for sharing all the work you've been doing on building CI here at Rancher. Darren, as always, thanks for diving into the code, and thank all of you for attending and asking so many great questions. Have a wonderful day. Thanks. Bye-bye.